Today we're going to talk about scatter plots. Scatter plots just show a relationship between two different datas. So this is made a scatter plot of the approximate population of Tampa, Florida. So what they've given you here is this table. It says years here, population in thousands. So this is not just 108, it's 108,000. So what we're going to do is we're going to first graph this, okay, and then we can look at, we can talk about it. Time in years or minutes or anything is always your x-axis. So that's why I've written it down here at the bottom. Let's go ahead and graph that. So I'm not going to start with 0 and go 10s or 20s. I'm going to start, let's say right here, I'm going to call that 1940. Oh. Hey, that's 1940. I'm sorry, it doesn't look very good. It's hard to write. I'm going to go about 3 or 4 lines. I'm going to go 3 lines and call that 1950. I'm just trying to space it out. This is 1960. So that would be 1970, 1980. 1990, and right there would be 2000. So that's my population years, okay, for Tampa, Florida. Now I want to scale the graph for population. So I want to say we came up with 20,000 for each line. So that'd be 20. This would be 40, 60, 80. 100,000, 20, 40, 60, 80, 200,000, 20, 40, 60, 80, 300,000. So we went, every line was 20,000. Then we graphed it. So we go 1940 and 108. Right about there. 1950 and 125. Right there. 1960 and 275. Right about there. 1970 is there in the middle. It's at 278, so it's just going to be a little bit bigger than that. 1980, it dips down a little bit. Not a lot. 1990 is 280, and then in 2000 it was above that, it's above 300. So right there. Now this isn't perfect, but it gives you an idea of what's going on, and you can talk about it. Sometimes it'll ask you to explain what's going on in the data. Well, as time goes on, what's happened to the population of Tampa, Florida? It's increasing. And then it might even ask, where's the biggest increase in population? Between what decades? Between 1950 and 1960, you can see it went from here 125 to 275. It more than doubled. See that big steep increase right here. And then you can see the population kind of leveled out. It even dipped down a little bit in the 80s. You could say maybe there was a hurricane that came through in one of those years. And then you can see a jump. It jumps almost 20,000 in 10 years. So maybe some new businesses moved in. Some new companies decided to build there. Something happened to the population and it started increasing again. All right, does that make sense? Hey, so by making a scatter plot, you can look at the data. It's a whole lot better than looking at these numbers. Numbers don't always make sense until you start looking at them in a visual way like this on a graph. It makes it a whole lot easier. All right, what I want you to do is write down types relationship. Underneath that, write positive, negative, and no relationship. And here in a minute, we will demonstrate what that looks like. So there's 3 different type of relationships that you'll see on the scatter plot. You have positive, negative, and no relationship. The first one is a positive. And what that means is X increases, Y increases. Here's what that looks like. Okay? The data is going up. As X gets bigger, so does Y. That's a positive relationship. Here's an example I use for that. The amount of study time versus your scores in the class. Though, if you study not very much, you're not going to have a very good grade. The longer you study, the higher your grade. That's a positive relationship. They positively affect each other. As one goes up, so does the other. That's a positive relationship. Everybody draw this. Let's draw a negative relationship. That means as X increases, my Y decreases. And here's what that looks like. A bunch of random dots, but you can see a pattern going on. That's the bigger X gets, the smaller Y does. Now, you might have one kind of over here that kind of defies what's going on in the data. That's an outlier. Hey, sometimes it's an anomaly. Sometimes it's just exception to the rule. But for the most part, you can see a pattern in what's going on. Example here would be how much time you spent playing video games versus your score in this class. The longer you play video games, the less time you study. So that's what. So it causes your grade to go down. All right? I'd say it's a pretty good example of a negative relationship. Any questions so far? All right. And here is no relationship. There is no pattern going on. It's a bunch of random dots that has absolutely no pattern. You cannot see a difference. Okay? Which means X doesn't affect Y. Here's the example I give. Your age versus your birth month. Does your birth month affect your age? Or does your age affect your birth month? No. Just because I was born in January, okay, if I was born in January, does that affect my age? Compared to you being born in February, does that mean I'm automatically older than you? No. Right? There's someone that might be born in January but might be born 4 years behind you. I was actually born in July, so some of you might have an earlier birthday in the year, but does that mean you're older than me? No. So that would be a no relationship. Your age does not affect your birth month, or your birth month does not affect your age. Make sense? Now, I want you guys to draw this down, and then we're going to, just to give you an example, even though I've already used this one, okay, this is a positive relationship. The more I study, the higher my scores are. So this would be a positive relationship. All right, and I know we've already kind of talked about it, but I just add this in here just so you can see and have an example. Any questions about positive and negative relationships? All right, here's your homework. 19 is one circled, so you owe me at least 3 complete sentences explaining the problem.